All right, can everyone hear me? How do you know if someone is from Texas? Don't worry, they'll tell you. So hey, I'm Jeff Duffy. I'm DocumentDB's Specialist Solution Architect. I'm from Austin, Texas. And I'm here today to talk to you about migrating to Amazon DocumentDB. So when we're thinking about migration, before we talk about the how or the what, I want to talk about the why. Like, why are you considering moving to Amazon DocumentDB? And so we talked to, surprisingly, a lot of customers from a lot of different kinds of databases who are interested in moving to a document store for all the advantages that it brings, and DocumentDB specifically because they want the advantages of an AWS managed service. And so we talked to customers who are using relational databases, right? Who maybe were using a relational database for a long period of time, legacy applications, maybe that's all that was available at the time. And now, they want the advantages of flexible schema and so forth that a document store can offer. Key value stores, even in-memory stores, we certainly talk to customers using things like Memcache or Redis who started that way because it was good enough. They didn't need the durability and persistence that a managed offering like DocumentDB can provide. But then they grew, right? Their app got bigger, more people were using it, and now they needed more features and more durability. Search, of course, is an important component of most applications, and services like Managed Elasticsearch are super useful for that. But it's also true that search-only services aren't typically the best choice to be the only system of record for an application, yet I talk to a lot of customers who end up starting out that way for one way or another, and again, as they grow and their application needs change, they want a store that's still as flexible as what they were getting before, but offers them, a higher level of durability and availability than they were getting with the solution they were using. And of course, in comparison to all of those sort of heterogeneous choices, we have the more homogeneous choice of coming from another document store. We talk to customers coming from document stores like maybe they're running Couch locally and they don't want to manage it, and they want to try something else. And so DocumentDB becomes an attractive solution for that. And it is possible to migrate from all of these different options that I just talked about to DocumentDB, and we've helped customers with every one of them. So when you're migrating to any database, but also especially DocumentDB, you're going to start with the discovery phase, and this is understanding what it is that you actually have, which sounds really obvious, but you'd be surprised at the number of people I talk to who say, well, the person who set this up, they're not around anymore, or they got promoted and they're off doing something else, and we really don't know a lot about the systems that are running today, and so we don't know what we don't know. And so discovery is what we do to help solve that problem, to know the scope of what it is we're trying to accomplish. Of course, then we need a migration plan. And the migration plan is the most important part of this whole process, because good migration plans mean happy people, and bad migration plans mean lots of people up in the middle of the night, probably on a Saturday. So testing, of course, is super important, especially important with any new managed service like Amazon DocumentDB, because you're going to want to make sure that you understand not just the APIs and what you're going to do in your code to use it, but what our architecture means for you in terms of your application's performance and your use. And then doing it, right? Executing, making it happen, bottles of champagne cracked afterwards after you're happy because you're running on DocDB and things are working well. So the purpose of the discovery phase, we have three main objectives, right? We're trying to make sure that from a compatibility perspective, you're going to be happy with what DocumentDB has to offer. And compatibility means different things depending on if you're coming from a document store or if you're coming from something like a relational database, where compatibility may not mean direct one-to-one API calls, but instead mean, can I format my data in a way that the schema makes sense for what my application still wants to do? So you need to understand what DocumentDB is going to cost you before you decide to move to it, of course, right? And part of the discovery process. It's important to understand what you can expect your bill to be, the dimensions in which we price, those instances, the I/O that we bill for, the storage, the backups, because you're going to want to make sure that it makes sense for you to migrate in the first place if the advantages don't outweigh the time and effort that it takes to move. Though, of course, we wouldn't be having this discussion if it didn't work out pretty well for most of the customers that I talk to. And then finally, you want to understand what your options are to migrate. And what this means is like, this is the how, right? So how many different hows do I have? And I'm going to pick one based not just because it's the one that, I learned about, but because you make informed decisions about what all the trade-offs exist, for time and difficulty and complexity of your migration. So if you're coming from MongoDB, which some customers are on premise, compatibility means understanding first what version you're coming from. DocumentDB is compatible with the Mongo 3.6 API. And so that means that if your source is not running on the Mongo 3.6 API, you're probably going to have to do some work in order to get yourself prepared for an easy move, right? And so this means that you're going to have to make sure that you follow the officially recommended upgrade path by MongoDB, right? So this is iterative steps. You can't just do a giant leap. This also means that you're going to need to think about your application's driver versions, which is something that a lot of customers tend to forget until it's like go day, and it's like, oh my gosh, we have this, set of things that we need to do in order to upgrade the versions of our drivers and run all our unit tests again and all the things that have to happen in order to make sure that, everything's going to go smoothly once you get there. It's worth noting, and I'm going to talk about tools a little more later, but we have a service called the Database Migration Service, which can help you migrate your databases to DocumentDB. And if the source that you're migrating from is MongoDB, DMS doesn't yet support MongoDB 4.0. So if you're running on MongoDB 4.0, you're going to have to think about one of the migration options that doesn't involve DMS. So if you're running Mongo and you want to migrate, you're going to need to think about what kind of deployment you have for your source. So you can deploy Mongo in a number of ways, of course. You can simply have a standalone MongoD running, right? That's just a process that's doing what it needs to do. And you can migrate from a standalone process, but your options are kind of limited because it doesn't have the operations log, the op log to use as a change data capture source, right? So if you want to use those more online options, you're going to have to convert it to a replica set in order to do so. This, luckily, is pretty easy. It more or less means running a single command. Most customers end up running replica sets who want to migrate. The important thing to think about from that perspective when we start thinking about using something like DMS to migrate. So MongoDB has this operations log. It's a log of changes that happens to your replica set. And you can change the size of it, right? It has this sort of default size that covers some default period of time. What that period of time is depends on how much stuff you're doing with your database. And you need to make sure that you understand what period of time that covers, because later on when we start doing planning, you're going to need to think about, hey, do I have enough time in my operations log changes to support what I'm trying to do, thinking about how long it's going to take me to do my migration. Sharded clusters are a deployment option for Mongo that many customers choose in order to address one or more limits that they've hit running replica sets. They want to scale to larger disk sizes than a single instance can hold, or they want to push more read throughput through their deployment than they can do with a single replica set. Maybe they need more write capacity. For whatever reason, sharded clusters are a deployment option that is more complex than the replica set or the standalone. But for the purposes of thinking about a migration, we can essentially think of sharded clusters as being individual replica sets, one per shard, because that is the approach that we will use when we start thinking about how to migrate that data to DocumentDB. The process basically looks like taking those shards in parallel and migrating them using whichever process that we choose. There are some things to think about with sharded clusters. They have a process called the balancer that moves data back and forth in order to try to keep those shards in balance. You got to turn that off, or you're going to get inconsistent data in your migration. They also can have documents left behind from failed moves of data back and forth called orphan documents that you have to go clean up. We talk about these details in our migration documentation in our website, but I just want to point out that the deployment type does have a lot to do with how complex your potential migration is going to be for Mongo, because the deployments themselves are more complex. Thinking about supported APIs and features is most impactful if you're thinking about migrating from Mongo. Of course, like I said, if you're migrating from another data source, of course, the features that we provide are going to matter to you, right? You're going to want to make sure that whatever it is you were doing in your previous data store is something that you can still continue to do here. But when I talk to most customers who are concerned about API compatibility, the thing to understand is that DocumentDB is not a drop-in replacement for Mongo, right? We released the service with the set of features that customers told us they had to have right away. We continue to add features to the service as time goes by based on direct customer feedback. But the upshot is that since it's not a direct drop-in replacement, there are going to be certain features that are not yet present in DocumentDB that it is possible you could be using with MongoDB today. And so we've documented those differences extensively, down to the point where we have documentation pages that have just giant tables of feature lists that have a yes or no next to them. So if you know that a specific feature is really important to you, you can go look in the documentation and see if you're getting a yes or a no in order to understand whether or not that would impact your migration. There are some functional differences in how DocumentDB works from Mongo specifically, and we're talking about here migrating from Mongo. These are also documented. They're mostly things like we don't sort by default, Mongo does. You know, if that matters to your application and you're taking dependencies on that behavior, you're going to need to understand that your new queries need to sort specifically, explicitly. So understanding those differences is also important because you don't want to discover different behavior from returned documents, of course, once you've migrated. We support virtually all of the data types that MongoDB does. The really notable exception is big decimal, decimal 128. We don't yet support, though we hope to soon. And there's also, I think, a native JavaScript data type we don't support as well, though I don't talk to too many customers who are using that. So limits, of course, matter too. When you're planning a migration, understanding what DocumentDB's limits are helps you decide how your deployment's going to look and thus how you're going to migrate to it. So the key ones to understand from a DocumentDB perspective are you can only have 64 terabytes of data in a single cluster. A single collection is 32 terabytes maximum in size. The document size is the same as Mongo, which is 16 megabytes. And there are a number of other implementation limits that may matter depending on your kind of deployment architecture. So a great example of what I mean here is that our instances have connection limits. And the limit itself is kind of based on the size of the instance that you're using. Bigger instances have more connections that you can use to them. But we often talk to customers when we're planning migrations who are running, you know, sort of microservice architecture deployments that are running on a bunch of containers in a Kubernetes cluster. And it turns out that their applications are using default pool settings. When they start up, they have 1,000 workers start. Each one only needs one connection, but they all fire up 50, and now all of a sudden they've overwhelmed all the connections in DocumentDB. Typically, just going and setting appropriate settings in your, worker will solve that problem. But understanding what limits exist and dealing with them before you get to the point where you're trying to migrate clearly is pretty key in making your migration successful. So sizing and costing next, you should absolutely understand what DocumentDB is going to cost you before you decide to migrate to it. And so in order to do appropriate costing, we need to gather some data from you, right? So we need to understand what your read and write traffic looks like. And so the particular key elements you need to understand, and the reason why, by the way, is the way that MongoDB or DocumentDB is priced is your instances, the I/O between your instances and your storage volume, the storage in your storage volume, and then if you're using backup above whatever your storage is. So for instance, if you have 50 terabytes of data in a cluster, you get 50 terabytes of backup for free, but anything over that, we're going to bill you at the backup rate, right? So in order to sort of calculate what all of these are going to be, we need this source data to make some estimates. And so starting with writes, right? We need to know, well, what does your average write load look like on a per second basis? And then what does the peak look like? Different customers have different workloads. Some customers are very bursty, some not so much. And it's easiest to calculate just if you know what the percentage of time is at peak, right? If I spend 20% of my time at peak, it's pretty easy to do some simple math and get us relatively close. And the same thing is true for reads, right? So I need to know what my read traffic is, and so I can calculate my read volumes. And the reason that these are so important is because it helps us choose what the best instance size is to comfortably process your traffic, and also estimate what the I/O is going to be from a costing perspective, right? So if you're running Mongo specifically and you want to migrate to DocumentDB, the easiest way to get that data I just described is to track what are called op counters over time. So op counters are just like monotonically increasing numbers that simply say, hey, at this particular point in time, this is how many of these operations I've run. So you have to track them over time because at any given instant, it's not as meaningful as seeing there's 50 more than a second ago. And they group up this way. So read traffics are queries and get mores, more or less from Mongo. Writes are inserts, updates, and deletes. There's a tool called MongoStat you can use in the CLI in order to go in and illustrate what those numbers might be. Knowing your average document size matters a lot because it helps us figure out how many IOs that are going to be generated from each document inserted. And of course, you want to know how much data you're going to be storing in DocumentDB. You're going to want to know how much that data grows on a monthly basis. And some workloads need to calculate on a per database basis. And the reason that I point this out is because it is not uncommon for customers to just expect that a migration is going to happen one for one, right? I'm going to take every single database, whatever that is, and migrate it to a DocumentDB cluster. But it turns out once you sit down and actually kind of critically look at that, a lot of times you discover that I can pack like 4 or 5 into a cluster pretty comfortably and save yourself some money as long as the other load issues are all kind of happy with what the instances are able to provide. So backup matters a lot. The good news is backup's super easy in DocumentDB. It happens automatically. It's turned on by default. We offer point-in-time recovery, but you actually need to know what your recovery point objective is to make sure that you're making the correct settings. We turn on point-in-time recovery automatically, and we do it for 24 hours. You can go like twist the knob basically to turn that all the way up to 35 days. And so the reason why you want to know and set it appropriately is, of course, this has a cost impact. Maybe not huge, but certainly not zero, and you want to make sure we're taking all the opportunities we can to optimize cost. Data retention is especially important to understand when we're thinking about moving to DocumentDB. So DocumentDB has this feature that a lot of other databases do as well called TTL, or time to live indexes. And you can create this index on a document that has a field that looks like a timestamp and say, once this document becomes so old, 12 hours old, 24 hours old, I want you to delete this document. And some customers and other databases have used this as a primary means of controlling the size of their data footprint. And so the reason why this needs to be carefully considered in DocumentDB is that we bill for I/O. So if you end up having a TTL index that deletes half your data, your I/O is going to be double of what it would normally because those deletes incur a cost. When we see this, we often talk about alternative strategies instead with customers. Do things like put all the data in collections by time and just drop them when you don't need the data anymore, because collection drops cost nothing. And so, it's easier on there. Rotating collections then is a primary approach. So when we're planning, again, we want to determine how big our cluster needs to be from all the data that we just gathered. We want to pick how we're going to migrate, the approach that we want to use, and then we want to create that test plan, which is, I said, all important. So the first consideration when we're figuring out what kind of deployment we want to do for DocumentDB is what your availability goal is, right? As defined in terms of numbers of 9s. And so typically the default DocumentDB deployment is going to be 3 instances deployed across 3 availability zones, which as you can see, that's going to give us 4 nines of availability. This is more often than not what most customers want as a bare minimum, and so it's why our default deployment is that. Now, you don't have to deploy 3 instances in DocumentDB. Our architecture uses shared storage, which means that durability is handled by the storage volume, not by instances. And so durability has nothing to do with that, right? And so what that lets us do is to make intelligent choices about how much availability I actually need and only spend as much money as I need to in order to, run my cluster. So you will often see customers who don't need 4 nines of availability for a dev test cluster, just run 1 instance in order to do so. And maybe if a customer has a workload that needs a little bit more availability than the 2 nines that we provide, they'll run 2 instances. The big difference between 1 and 2 is that if you're running a single instance in a cluster and that instance dies, we have to replace it wholesale. It takes us 8 to 10 10 minutes to do so. If you have 2, we fail over instead to the other instance, which is a replica at that time, and that takes 30 seconds or less. So there's a pretty big difference in availability and time perspective between 1 and 2 instances. But when we go from 2 to 3, what we're really doing is then leveraging the AWS global infrastructure and the availability zones in order to just give you that extra level of availability. So from a performance perspective, because our service is instance-based, right, the instances have an awful lot to do with how fast you're going to be able to go when you're reading and writing from your database. And so clearly, the number of CPUs and their speed is going to have an impact on the processing of your queries. Now, different kinds of queries may use CPU more or less, and that is also going to impact how you use DocumentDB. But generally speaking, if you're doing things like building indexes or maybe doing some complicated aggregations with some sorts and so forth, it could use a lot more CPU than some very simple just fetch queries for a document. So working set memory is super important. Working set memory is the RAM that's left over after the engine is doing its thing, where your database pages can be stored after they've been retrieved. So the next time you go and you ask for the same data, we give it to you again out of memory. We don't go to the storage volume. And this is awesome for 2 reasons, because it's way faster, and we don't charge you for that because you're not doing any I/O to the storage volume. And so when you can, if it's possible, you want to keep as much as possible in working set memory, right? It's so important that we built a CloudWatch metric into the cluster for this that reports to CloudWatch. It's called buffer cache hit ratio. It's a percentage of how many of the pages you've asked for have come out of that working set memory. And so in the smaller instance sizes in the R5 family, from like large to 2x large, you get like 2/3 of the available RAM as working set memory. When we get to the bigger instance sizes, like all the way up to 24x large, the percentage is way bigger because we don't need that much to run the engine, like clearly, right? But sitting down and looking at your data, thinking about, not only like, what do I think I'm going to need to store in working set memory in terms of the data itself, but indexes are a key thing. If you're building indexes and you have a lot of them, you're going to want to think about your instance sizing to make sure those indexes can fit in memory whenever possible, because index lookups are faster, index lookups from memory are faster, and we want to do that as much as possible. So the read and write velocity, of course, like we talked about before, the bigger your instance, the more reads and writes you're going to be able to push through it. I often get asked, by the way, from a performance perspective about bandwidth. In other words, should I worry about how much bandwidth is between the instances and the storage volume? And the answer is no, because we always make sure that there is more bandwidth and capacity between the instance and the volume than you can physically push through the front interface of the instance. So from that perspective, you don't have to worry about it. So migration approach is one of the kind of key things to really consider when we're thinking about our migration, because the approach we choose defines what we're going to do and how complex it is. So there's a number of migration tools that you can use to migrate. Which tools you're going to be able to use depend in part on what you're migrating from. In this case, I give some examples of customers who might be moving from, let's say, MongoDB on-premise, right? So MongoDB comes with some tools called MongoDump and MongoRestore that can take data out of MongoDB and dump it to disk in the binary format. Restore takes that binary format and restores it back to Mongo. These tools work with DocumentDB just fine, and so you can use that as an approach to move data. Mongo export can pull data out and put it in a different than the binary format, JSON or CSV. And then this is the key, the Mongo import tool can take that JSON or CSV and push it back in. And so what you can do is use the Mongo import tool to take data exported from a non-Mongo source, like a relational database maybe, and take CSV data or JSON output data and import that into DocumentDB. Both of these sets of tools, by the way, allow filtering, and that's worth noting because it's pretty common that customers may not want to move actually all the data they used to have. It's a relatively frequent conversation I have where they say, well, we had 10 years of data, but we only actually want to move 1 year of it because we don't want to have to size up the cluster to keep all this old stuff around. The other reason that this is so important is because while I talked about different database types and what to move from, sometimes we talk to customers who are actually moving to DocumentDB from S3, right? They had flat file data sitting around that they wanted to query, and Athena is great for data that's sitting at rest. You can use Redshift Spectrum to do that too, but they've decided that they want that data available in a more online fashion, and so you can use Mongo import depending on the source file type, right, the format, to just move that data into DocumentDB if you decide that's the correct place for it to live. So it turns out that those MongoDB tools don't allow you to do an important thing, which is to create your indexes before you restore data. And this is especially useful in DocumentDB because our index builds are single-threaded. But if an index already exists and you push data in parallel, the index gets updated in parallel, and that's a lot faster. So as you'll see in a second, when I talk about the different ways to migrate data into DocumentDB, I always want you to build your indexes first. Now, clearly, if you're moving from, say, a relational database, you're going to have to define those indexes by hand. It's not easy to just automatically translate the definition of an index from a different file format to this. But if you are moving from MongoDB, then we have built a tool called the DocumentDB index tool. It's on the AWS Labs GitHub repo, open source, written in Python, very few dependencies. And this tool does two things. It will export indexes from a running MongoDB, or actually you can use a Mongo dump that already exists if you use that tool for backups, right? And it will import those indexes and create them in DocumentDB. So you can do them first before you put the data in DocumentDB. This tool also has a couple extra features that let you do things like check for index compatibility and such if that ends up being important for your application. So there are four basic approaches to migration I want to talk about, and the first is called the offline approach, and this effectively is a dump and restore, right? We're just going to stop writing to our source database, whatever it is. I'm going to dump my indexes and data. I am going to restore indexes with the index tool if it's useful for that particular use case. If you're coming from a relational database, maybe you just create these by hand, right? But then I'm going to restore that data using an appropriate tool, Mongo Restore, Mongo Import, maybe a tool that you write yourself. We've seen customers do that coming from some other sources. But the basic idea here is that this is the simplest approach, and then your application should, of course, use DocumentDB once you've moved the data. So this is the simplest approach because it's a straight up dump and restore with some thought put to your index strategy, right? And it's fast. It is the fastest method. If you're using the Mongo the Mongo Restore tools and the Mongo Import tools, they even have a knob built into them to let you increase the parallelism of the restore. And so we've done internal testing and verified that you can, for instance, create a really big DocumentDB primary of our largest instance type, really increase the parallelism of that restore, and the restores go very fast. And then once you're done, of course, you can just destroy your current primary, create a new one. You would probably fail over to a smaller one, and then just use the size that you actually needed. Because it's so easy to create and destroy replicas and fail over, it's very straightforward to manage those sizes back and forth as you're migrating. But it does have the longest downtime, right? Because clearly if you have to stop writing to your source, then nothing good is going to happen with your data until you get migrated over and can start using DocumentDB. So the online approach uses the AWS Database Migration Service, and DMS is capable of migrating a number of different database types to DocumentDB. It's not just MongoDB. So DMS supports MySQL, for instance, as a source, right? And so the way that this works is that you're going to keep on writing to your source, right? You don't have to take this downtime. If you're using Mongo, you can dump indexes with the DocumentDB index tool. In either case, you're going to either restore or create those indexes first in DocumentDB. And the reason that you're doing this in this case is not for speed, but because DMS doesn't move indexes at all. So you have to do it yourself before you start using DMS. And then DMS is capable of initiating a task in either full load or full load in CDC. And what this means is full load is dump all the data from my source and push it into DocumentDB, and then CDC clearly is change data capture, right? It's move the changes that happen over to DocumentDB. So the online approach basically relies on DMS to move all of the data for you, and then once all the data is moved, to start just tracking the changes that happen. And then once you've reached a point where you feel like you're at an acceptable amount of replication delay between DocumentDB and your source, you cut your application over by changing the endpoint and start using DocumentDB. And so this approach is good because it has the least downtime available, right? We don't have to wait while we dump and restore before we can start using our application again. The complexity is, I call it medium, right? Because you've got to learn a new tool. You have to understand how to use DMS, which you probably didn't until you started on this particular journey. And it's the slowest method. DMS is single-threaded. It is something like 3 to 5 times slower than a dump and restore at max parallelism, which matters for customers with larger data sets. Typically speaking, we see customers who are moving 500 gig to a terabyte or less, fairly happy with the performance of DMS alone as a migration strategy. But once we start getting to more data than that, which is pretty common, then we look at the hybrid approach. Clicking around. So the hybrid approach takes the first 2 approaches I talked about and it smashes them together, right? So we're going to keep on writing to our source, but we're going to actually dump our data in indexes. And we're going to remember when we did this. We're going to call this time like time T0. We're going to restore our indexes with the index tool or create them by hand, and we're going to restore our data in parallel to take advantage of that super fast restore. And then we're going to tell DMS, hey, start trailing changes from my source. And you know what? I want you to start, I don't know, if we're talking about Mongo, 5 minutes before T0. Mongo's op log is idempotent. It's okay if you apply changes multiple times. If you're coming from a relational source, maybe you just try to hit the right minute, right? So you don't get duplication in your documents. But the basic idea here is that we're doing a dump and restore for speed, and we're layering DMS on top to get you that low downtime. So the downtime is still minimal, and it is absolutely faster than online for data sets, we'll say larger than a terabyte, but it is also the most complex approach. If you look here, there's a lot of moving parts, there's a lot going on, right? So it's worth noting that I have a lot of customers that take this approach, and it works great for them, but it's clearly not the simplest way to do things. Finally, I'll just point out that the dual write approach is often used by customers who have existing workloads running on relational data stores because it's easier for them to do this than to worry about the other approaches I talked about. You just keep writing your source and you update your code, right, to also write to DocumentDB, and in the background we're going to dump and restore potentially if you want to speed up the process, if you want to get your source data and start getting caught up. And then you can continue writing to DocumentDB as a dual write, and then once you feel like you're happy with it, you can cut over to DocDB by pointing your application over to DocDB. And so, clearly this is going to be the most impactful to your application. You have to go change code, right, to do it. But I most often see this approach for customers who are coming from non-document stores. So, a couple quick notes about test plans. So, I just point these out because they're things I've seen customers fail to do and then suffer from later, and I wanted to save you from this pain. The test plan is ultra important. You've got to get it right. It's got to be detailed. Make sure you define your migration goals in super, super detail, right? You need to know when you want to do it and how you want to do it, and you need to know what success looks like, right? Like, how do you know you've won? Right? Everybody needs to understand what that is. You need to detail every single step in your test plan. I see lots of customers use Excel spreadsheets successfully because they like to roll out the columns and say this person owns this and this is what has to happen. But know who owns it, know how long it should take, know if you need to stop and go back because something went sideways, and understand what you are going to do if stuff doesn't go well. I also want to point out that during testing, you see a lot of customers that will try to do a migration like on a Saturday because that's when everybody likes to do it with minimum downtime. That is a terrible idea because if something goes sideways, everybody that you need to help you fix the problem is probably off at a football game, right? So a lot of our customers have moved from the weekends to the middle of the week because they find out that it provides them a better response time if they need help. So make sure you actually test your workload. Don't just run YCSB or something else like that. Figure out a way to take a shadow workload and point it at DocumentDB. We have a different architecture. It means we have different performance envelopes. We are confident that we're going to be able to run your applications the way that you need to, but we want you to test it and not take our word for it, right? Make sure that when you run through your test plan for your migration, that you record how long it takes. That's a key component of migration, is understanding the elapsed time. And have the same people actually do this that tested it. This seems also super obvious, and yet I often find that you'll take somebody who is maybe a junior dev who's learning your system and say, hey, can you go off and test this and see if this plan looks like it works? And then, of course, your senior people will be on hand to make sure your application doesn't fall over and they missed some key element that looked weird when somebody tried it before. So I would like to invite to tell you his story of migration to DocumentDB, our customer, Ranga Rajagopal, Senior Director at FINRA.
Thanks, Jeff.
Yeah, my pleasure. Thank you.
Hello, everyone. My name is Ranga Rajagopal. I'm a Senior Director at FINRA. I manage all of the data collection and data dissemination platforms at FINRA. So the agenda for what I'm going to cover, I'm going to briefly talk about who FINRA is, our AWS footprint, just to give you, we are pretty much a very matured AWS shop. So we started our cloud journey back in 2014, moved all our big data workloads to the cloud, and then in the last 4 or 5 years, we've been moving all of the other workloads. So we are constantly migrating to the newer AWS services and more moving to managed services, and that's what I'm here to talk about. I'm going to talk about how we are planning to use the DocumentDB for our new data collection platform called DCAF that we are building right now. And then I'll talk about our benefits and then our future roadmap items for our data collection platform. So for those of you who do not know who FINRA is, so we are Financial Regulatory Authority, and we are one of the largest securities industry regulator in US. We regulate close to 3,700 plus brokers in US. Brokers means, I think, companies like Merrill Lynch, Goldman Sachs, these are the broker dealers. And then we also surveil all of the equities exchanges in US, like New York Stock Exchange, NASDAQ, and most of the options stock exchange. So as I said earlier, I think we started our AWS journey as a big data migration strategy. And then as you can see from our highlights, we process up to 135 billion transactions per day at peak. And a lot of data, a lot of validations, half trillion validations runs per day on our big data processing. And in our EMRs, we run about 50,000 nodes at peak when we're doing our big data processing. But today I'm not going to talk a lot about big data. I'm going to more focus on our middle circle here, where I think we are focusing on building our data collection platforms, where all the broker dealers and the brokers that work for the broker dealers will start submitting data to us using the data collection platform. I want to give just an overview of our data ecosystem. We have a pretty sophisticated data management process on the left, which is open sourced. You can go to our FINRA open source. You can Google for FINRA open source, and then you will find HERD, which is our open source data management system, which is built on top of S3, which is our data lake. We have pretty much every data that we have in FINRA in our S3 data lake. And we have all our computes. We use a lot of ETL and analytics in our compute, EMRs and Spark and Hive. And mainly I'm going to focus on the storage. As you can see, we use S3 and we use Elasticsearch. Now with this new architecture for our data collection, we are going to start using Amazon DocumentDB as our primary operational data store for all our filing data collections. So what does our data collection platform do? We collect a lot of regulatory filings from our broker dealers and the brokers that work in the broker dealers. You can think about more like the tax filings that we do for 1040 every year, something very similar. The broker dealers submit about close to 100 plus regulatory filings every year, something like financial data, or if a broker have to be employed with the broker dealer, they have to send all the brokers' personal information, all their disclosures, a lot of information that we collect from all these brokers throughout US. And as you can see from the numbers, this is a number from our 2018 statistics. About 200,000 users use our data collection systems, and we have about close to 44,000 external firms that actually access these systems, and roughly about 2.7 million filings and about 1.3 million, about 4 million documents to overall, I think, we collect from these broker-dealers. So this is what we have in our current data collection framework. Nothing wrong with the architecture except that it was built about 10 years back, and I think it's about time. And as I said earlier, we are a very matured AWS shop, and we are constantly looking for opportunities to move to an AWS managed service. And I think currently we store all of our data in XML, and then it takes a lot of storage, and we have a lot of custom tools that we have built for parsing the data. And when we are building our data collection platforms, all our forms, layout, and schema, these are all coupled in XML. So every time we make a change, we have to have a lot of impact to our downstream consumers. So we were in the process of moving to a new platform, and then it was a perfect timing that I think roughly about, January of 2019, AWS announced about DocumentDB, and then at the time I told my team, hey, let's go take a look at this, because this is what we should be using for our data collection platform. So I think we were already in a plan to move to a new data collection framework, and I think the DocumentDB came at an exact perfect time for us, and then we decided to fully invest on using DocumentDB. So I think we have written a lot of custom code for versioning, and we have written a lot of custom code for workflows and everything, and now we are moving to a new framework where everything is mostly going through an AWS managed service, which I will talk about shortly. This is our current platform. I'm going to mainly focus on what's in the middle layer there, our data intake services. As I said earlier, nothing wrong with the architecture. As it's already in AWS. We did a lift and shift strategy about a couple of years back on the current architecture. So we have our UI services running on top of EC2, and we have our workflow services, again, running on top of EC2, and we use RDS for each of these services, backed by the RDS for the data. And then we have our own search service running on Lucene, and all of these actually managed by us right now. So we have code running, so anytime we have a problem, I think it's our team that we have to figure out how to debug and fix. And with moving to the managed service, I think we spend more time writing the business code and writing other things, not worry about the infrastructure that we have to manage. So the DCAF is the new data collection framework that we are planning to launch in March of 2020, where it will be powered by the Amazon DocumentDB. And this is our DCAF architecture. As you can see, we get a lot of files from the broker-dealers. On the left, you can see our users will send us files either through SFTP, or they'll send us files through direct APIs, or they will use browsers and upload documents using browsers. So they all will come through a common API layer, which we call actually as our common data collection API layer. And then once those API layer is passed, they will all be going to our Amazon DocumentDB store. And then once it is stored, we will actually send notifications using SNS to our downstream consumers so that they can actually pick up anything that they need from our systems. And also, we are also in parallel working on writing small utilities. Again, I think Jeff covered about the migration utilities that he talked about. I think we are doing something very similar for our own purpose, where we are moving all the existing data that's sitting in our relational database and converting them to a JSON, and then putting it through our actual filing system so that it can go into the DocumentDB. We are also doing another thing, which is more like a reverse, because we still have downstream consumers who are still using our relational data store actually as the interface. So we are doing a reverse of actually taking these JSON and then converting it to a relational data store and then putting it in a PostgreSQL RDS, because on day one, we cannot expect every single consumer of our system to move to our new APIs. So we are actually going to run in parallel and put them in a relational data store so that they can actually slowly move to our new APIs when we launch this new platform. I think I talked about it earlier. I think our volume is roughly about 4 million documents every year, a lot of complex business rules. And again, one of the reasons that we picked a managed service is we are big in requirements around security, audit, versioning, records management, all of these are very important to us. So by going to a managed service, like using DocumentDB, Elasticsearch, I think we get all of these things free for us so that we do not have to worry about building a lot of this by ourselves. Just a quick comparison on our current usage and what we are going to see with DocumentDB. So in our relational database, this data is stored in tables and fields. And I think in the DocumentDB, it will be natively stored actually as JSON document. Because all of our new APIs, JSON is our standard. So by putting it in a JSON document structure, it makes our translation very easy. So we do not have to worry about converting it from JSON to any other structure or like XML or anything like that. And also any changes is managed more in custom code right now. When a data changes, I think we are using the change detection from streams to automatically automatically have the detection for the change streams. The queries is another thing. When you try to do a lookup query against multiple fields, I think again, we have to write like custom SQLs on how to query on multiple fields in each of our tables and columns. Because it's JSON, we are able to easily do flexible lookups for our queries. Another big advantage for us is the model-driven development. When we build the platform, we decided to do a JSON model-driven development. So all of these are huge forms and filings with a lot of fields. I think our largest form has about close to some 4,000 fields in it. So we start working on our development by building the JSON model first. So we started with the JSON model, and then that's our base. And then the same JSON model is used in our UI framework, and the same JSON model is used in our APIs, and then the same JSON document is stored in Amazon DocumentDB. So that makes our life extremely easy from an SDLC and development perspective. Another thing is about skills of the resources that you want to keep for this. I think with Amazon DocumentDB, our regular cross-functional engineers are able to easily pick up the basics, and they're able to easily get into the velocity of the team very easily compared to using any of very traditional relational services. I think I talked about this earlier. What are the benefits that we are seeing? We do not need a transformation layer between our data and the APIs because everything is natively stored in JSON documents, and our APIs are fully using JSON, so there is no transformation layer. And we have very high SLA requirements around scalability and availability, and those are all, like fully coming with an AWS managed service here. And one of our big architecture goal is moving into AWS managed services. Right now, we are moving all of our search to Elasticsearch, and then all of our documents will go to the managed Amazon DocumentDB. So I think moving to a managed service is very important for us, so that we spend, as I said, we spend our time more writing business functionality and other challenges that we have to face, not worrying about the infrastructure at all. So what are our future use cases? So by March of 2020, when we have this new data collection platform running in production, the next thing that we want to do is move all of our current registration systems, which, as you can see from the slide here, have a lot of, it's running on an Windows environment right now. Again, it's running on AWS, it's running on a Windows instance, and a lot of .NET code, and it uses RDS, a lot of tables. We want to migrate all of these data collection, the legacy data collection that we have on registration systems. By end of 2020, we want to move all of them into the new data collection framework, the DCAF that we are planning to build. The same thing that I just spoke about, I think all of the registration data and documents will move into the new data collection platform that we are building by the end of 2020. So this is our end of 2020 architecture. Again, I think nothing different from the earlier architecture that I mentioned. The big thing that we are focusing is we are trying to keep a parallel environment on the top, because we will not be able to move all of our consumers on day one. So we are still keeping the old system running on the top, and we are actually running a bridge between the old system and the new system. so that they can continue to operate in parallel, and eventually, after about 12 to 18 months, we will slowly shut down the old system, and then we would expect all of our consumers to fully move to the new system. One thing on the top that I want to mention is the FileX. Again, very similar to the way the Amazon DocumentDB, how we are using. About a year back, we wanted to move to a managed SFTP service, and the FileX there actually on the top is we use the Amazon's managed AWS SFTP service, and I think I'm going through a very similar exercise right now and moving through AWS managed document service by going to Amazon DocumentDB. So I think our plan is to move all our platforms and services into all of the available AWS managed services. That's it from my side. And I think, what should I say about this, Jeff? I think you should go and look at the trainings.
Yeah, turn my mic back on. That's all right, I'm loud, I can just yell. Okay. So thank you very much. Appreciate that.
Yeah.
Excellent story. Is this on? Yeah. Great, I've turned on just in time to finish. So, yep, you should definitely try to go learn more about DocumentDB if you're interested in our website. Of course, AWS certification and training is available. And I think I have a minute or two if you'd like to come up and ask a question. So thanks a lot for coming, and I appreciate your time. Thanks.
Thank you.